Hi viewers, welcome to my channel Naveen Velchuri. In today's video, I am going to design and simulate a 2-input NAND gate by using CMOS logic. If you observe here, for designing of 2-input NAND gate, we require 2 PMOSs and 2 NMOSs. If then for both the inputs are active high, then only output will be active low, and remaining all cases it will be active 1. So just the operation of a NAND gate is opposite of a 2 input AND gate. So to design this 2 input NAND gate, first of all we will go for two basic rules that all the NMOSs in a NAND relation should be connected in series and all the PMOSs in NAND relation should be connected in parallel. And all the NMOSs in NOR relation should be connected in parallel and PMOSs should be connected in series connection. కంపల్సరీ ఎప్పుడైనా కానీ మనం నాండ్ రిలేషన్లో ఎన్మాసెస్ అన్నీ కూడా మనం సిరీస్లో పీమాసెస్ అన్ని ప్యారలల్లో నార్ రిలేషన్లో ఎన్మాసెస్ అన్ని ప్యారలలు పీమాసెస్ అన్ని సిరీస్లో కనెక్ట్ చేయాలండి. సో ఇక్కడ చూస్తే నౌ ఇఫ్ యూ అబ్జర్వ్ ది ఆర్ ద డిఫరెంట్ సింబల్స్ ఆఫ్ ఎన్మాస్ అండ్ పీమాస్ రిప్రజెంటేషన్స్ వి మేడ్. Here NMOS will be represented simply with a gate, drain and source terminal, and PMOS will be represented with the bubbles. Based on that rule, both PMOSs should be connected in parallel. Parallel means both drain of PMOS and source of PMOS should be connected. And in the series means NMOS one transistor drain is connected with source of another NMOS. Now by using a DSCH tool, I am going to design this 2-input NAND gate. Here I am taking the two PMOS symbols and both will be I am placing in a parallel connection. If you want to know the terminals of PMOS transistors, then if you click on that particular transistor symbol, then you will get those values. Here see that channel width and channel length we will represent. If you click on show the pins and transistor names and terminal names, then we will get gate, source and drain terminal names and their width and length values. Similarly for the second transistor also I am doing the same thing. Drain and drain of PMOS and source of PMOS should be connected in parallel with a line. Then you will get a parallel connection of two PMOSs. And similarly, I am taking the two NMOS transistors that should be connected in series connection. సో రెండు ట్రాన్సిస్టర్స్ని మనం ఇప్పుడు సిరీస్లో కనెక్ట్ చేయాలి కాబట్టి టూ ట్రాన్సిస్టర్స్ నేను తీసుకున్నా. ఇప్పుడు వీటి యొక్క టెర్మినల్స్ కూడా మనం అబ్జర్వ్ చేస్తే సో సీ దట్ గేట్, source and drain. Similarly, gate, source and drain terminals I have taken. The source of first NMOS and drain of second NMOS are connected together, then it will become as series connection. సో ఎలా అయితే టూ పర్సన్స్ ఒక లైన్లో నిలబడితే సిరీస్లో నిలబడాలంటే ఒకళ్ళ రైట్ హ్యాండ్ ఒకళ్ళ లెఫ్ట్ హ్యాండ్ ఎలా అయితే మనం కనెక్ట్ చేస్తామో అదేవిధంగా సిరీస్ కనెక్షన్ ఆఫ్ ట్రాన్సిస్టర్స్ అంటే సోర్స్ డ్రైన్తో కనెక్ట్ చేస్తాం. నౌ ఐఎమ్ కంబైనింగ్ దిస్ PMOS అండ్ NMOS ట్రాన్సిస్టర్స్ విత్ హెల్ప్ ఆఫ్ ఎ లైన్. యాక్చువల్గా మెటల్ లైన్ తీసుకుంటాం కనెక్ట్ చేయడానికి. అండ్ VDD వీఆర్ అప్లయింగ్ టు ద సోర్స్ ఆఫ్ PMOS. And for the source of NMOS we are connecting the ground terminal. Now we have to apply two common inputs for the NMOS and PMOS, and for another pair of PMOS and NMOS we have to connect input terminals. To represent those input terminals, take the two buttons. I am representing the input value as A, and for the second one I will represent the input value as B. It will be connecting with a line, and to observe the output value I am placing an LED component here. Now take that wire and connect the drain. Combination of PMOS and NMOS will be connected with an output value, and by using a wire A is connected with one PMOS and another PMOS. It is a pair, and similarly another NMOS and PMOS will be connected with the wire to get the second pair of the combination of transistors. This will form a 2-input NAND gate circuit. Now after designing this circuit, we have to save that particular circuit. So to save that, first of all, you have to select the nanometer technology you have to design, that will be selected by using a selector foundry. After that, you have to save your particular design in your. After that, you have to save the Verilog file which was generated for your design. So it shows the hierarchy value and netlist value as said in the previous video inverter. So similarly here also we are designing. After that you have to generate a spice file to verify DC analysis, AC analysis and transient. If you observe the transient analysis here, you will get the input combinations of 2 0 0 0 1 1 0 1 1. You may get the output value only as an active when both the inputs are active high. Similarly, the DC analysis also we may observe. Now we are going to generate logic symbol. So click on the schema to new symbol. In this, wherever the folder you are going to save, that path will be given and you have to click on OK to save the symbol for that one. So compulsory we have to maintain these three .sch schematic file, .v Verilog file and .sym symbol file. After that, go to the simulate and here we are applying the logic simulation option. Then you will get the simulated output in a truth table format. If you generate the truth table value, then when logic both will be active high, then only you are getting the active low output value. In remaining all cases it will be active high because it is a NAND operation. Thus, in this way, we will verify the output of a 2-input NAND gate. If you observe the operation of how the transistors are going active high and active low, see here in manually applying the 2-input values. Here both the inputs I have applied as logic 1. Then you observe both the PMOSes are in off state, that is open state, and both NMOSes are in on condition. So whenever both PMOSes are in off, though no VDD supply is available for the NMOS transistors, so whatever available charge is there at the drain of one NMOS is passes through the another NMOS and that will be sinks into the ground, then automatically output will be 0. When both the inputs are 0 0, then also there is no output we are getting as active low because the supply VDD is available uh, when the PMOSes both are in active state, so we are getting the output value. So in this way, the 2-input NAND gate. So in remaining all cases, if you observe 0 1 value for the input values, then one PMOS will be in the active and another PMOS will be in the inactive position. So wherever the supply is available, that will be getting at the output side.